Hi, Mr. Biggers here, and today we're going to go through our Unit 6, Lesson 2 on triangle similarity theorems. So today we're going to be talking about triangle similarity, which is different than triangle congruence. Triangle similarity states that two shapes are the same exact shape, however, their size could be different. Congruency would be like, okay, this shape is exactly identical to another shape. Similarity says that the shapes are the same, they're just bigger or smaller. Or, if you remember, a dilation, okay? So there are three ways that we can prove that triangles are similar to each other. One of these three ways is angle-angle similarity, okay? The other way is a side-side-side similarity. And on the back side of our page here is side-angle-side similarity. So we're going to talk about these three different types of similarity on today's notes, and then we're going to do some practice problems with them. Angle-angle similarity says that if two corresponding angles are congruent, then the triangles are similar. So we can look here and see that angle A is 75 degrees, and so is angle D. So we know the measure of those angles is congruent. Angle C is 31 degrees, and so is angle F. Okay, because we have two angles that are congruent, we have enough information to say that these triangles are similar by angle-angle similarity. Similarity is going to use this symbol, okay? This means similar. So you will see this often in our problems, okay? So the similarity statement is still going to follow the correct sequence of ordering. So we're going to have triangle ABC is similar to triangle DEF. Remember the order matters on those. A would correspond with angle D, E would correspond with B, and obviously C would correspond with F. Keep that in mind. Pause the video, see if you can figure out this one. I'm going to go ahead and go over it now. So we are given from the diagram that angle V is congruent to angle Y. We are also given that there is an X occurring in our diagram, which means X marks the spot. We have vertical angles that are congruent. So I'm going to write that down. That way we have it for reference. Okay, always mark your X marks the spot. Vertical angles are congruent. Because we have two congruent angles, we now have enough information to say that the two triangles are similar by angle-angle similarity. Okay, if we write the congruence statement here, we're going to get triangle WXV is similar to triangle ZXY. Remember, the order matters. Okay. So over here on side-side-side similarity, you are going to need a calculator because we do need to calculate some of these proportions and how they work, okay? So if all corresponding sides are proportional, remember that's two fractions that are equivalent, then the triangles are similar. Okay, so what we need to do here is determine if the examples below are similar by side-side-side similarity. If they are, write a similar statement. Okay, so QP is going to correspond with TS. Okay, so what we do here is we set up a proportion to represent that. It's going to be 3/6. Now the relationship of those two sides, 3 relates to 6 in the same exact way that 5 relates to 10. And then it needs to also be proportionate to the relationship of 4 to 8. So in this particular problem, I'm taking the values from the small figure and comparing them to the values of the big figure. Okay, make sure you stay consistent. Okay, so for this problem, I did small over big. You can choose whichever shape that you want to start with for these problems. Okay, when you type this in your calculator, this is typed in as just 3 divided by 6. When you do that, you get 0.5. I'm going to quickly type in the rest. You can pause the video and see if you can type these in the calculator. They all come out to 0.5. Since their sides are what's called proportional, since all of these values are equal to each other, that means we know the two triangles are similar by side-side-side similarity. I'm going to skip the writing of the similarity statement, okay? So this one I'm going to set up and see When the triangles are a little bit hard to see what matches with what side or what corresponds, I always start with my largest side. So my largest side in triangle CDE is 35. The largest side in triangle FGH is 28. So I'm going to compare those two sides, 35 over 28. We know the relationship of those sides needs to be equal to the relationship of the two small sides. So my smallest side on the triangle to the left is 30. The smallest side on the triangle to the right is 24. So it needs to be equal to the relationship of 30 to 24. Also, it needs to be equal to the relationship between 32 and 25. If these are proportional, if they relate to each other, then we have enough information to say that the triangle on the left is similar to the triangle on the right. So we're going to quickly type these into our calculators. 35 divided by 28 is 1.25. 30 divided by 24 is 1.25. And 32 divided by 25 is 1.28. So this is similar, however, this is not because the values are not proportionate. They are not equal. So these are not similar. Not enough information is given, okay? You need those relationships to be proportionate. And for number 4, you can notice here I took all the values of the big triangle are in the numerator of the fractions over all the values of the small triangle. So this one I did big over small. It does not matter what you do, just make sure each fraction that you set up is consistent to your rule, whichever that you decide, okay? So we're gonna do some practice here. So for angle similarity, I'm gonna go a little quicker through these practice, so if you need to slow the video speed down or anything of the sort, please do so. But we have angle similarity, okay? So how do these have angle similarity? Well, angle E is congruent in both figures because vertical angles are congruent. We also have a situation here with these triangles. If you have those markings in geometry, that means you have parallel lines, okay? We remember back from our previous lesson that there's some relationships that exist within parallel lines. The relationships are going to be that angle C here is congruent to angle G over here because those are alternate interior angles and they're congruent, okay? Because of that definition with the relationship of parallel lines, we now have two angles that are congruent to each other. Because there are two angles, these two triangles are congruent by angle similarity. And the similarity statement would be triangle CDE is similar to triangle GFE. Remember, the order matters on the similarity statement. Okay? On number 2, we still have angle similarity, but we need to see how. Okay, so angle L is congruent to itself. When something is congruent to itself, that is known as the reflexive property. Okay, we also have another pair of parallel lines you can see with the little triangles that are marked. So if you have parallel lines, you also know that their corresponding angles are congruent. So angle P is congruent to angle N because corresponding angles are congruent. Okay, and because we have the two angles that are congruent, we know those two triangles are similar with angle similarity. I know a few of us might have a question on how are there two triangles in this picture. I see one triangle with a line down the middle. So you kind of want to think of it as you have this little triangle that I just outlined in green. So that's your little triangle. And they're trying to ask you, is your little triangle similar to your big triangle? Remember, similar means that they have all the same angles, but the sides, the relationship between the sides is proportionate. These two triangles are similar, so the similarity statement is going to be triangle QPL is similar to triangle MNL. Okay? So down here we have our side similarity, so we need to set up our proportions. to see if they're equal. I'm going to get us set up on number 7. Pause the video when I tell you and see if you can figure it out. So once again, I'm going to start with the smallest side over in this triangle and the smallest side in this triangle. So 9 over 14, that's small over big, okay? Now I need to look at the largest side. The largest side is 20.25 over here. Pause the video at this time, see if you can set up the other two. I'm going to keep going now, though. And this is 31.5. And then you've got 13.5 on the top because it's from the small figure, and the small side on the large figure. Or sorry, not the small side on the large figure, but the corresponding side on the large figure would be 21. We're going to type all these values in the calculator quickly here, and we're going to see if we get an answer that's equal. So when I type this one in, it's 0.64. This one is also 0.64, and this one is also 0.64. Because the relationships are equal to each other, we know the two triangles are congruent by side, or not congruent, they are similar by side, similarity, okay? So this one does work. I'm going to skip the writing of the similarity statement just because I don't have a lot of room. Okay, number 8. Like I said, pause the video, see if you can figure this one out. I'm going to go ahead and work it out for us now, though, okay? So we need to figure out, there's two triangles in this problem. They want us to see, are they similar or not? One of my triangles is this blue triangle. It's the little triangle. The other triangle they're talking about in this problem is the larger triangle here, what I'm outlining in green, okay? So we need to look at the given information and see if that's enough to say that it is side, similarity, okay? So we're going to take the little triangle first. So I'm looking here at the bottom. I can see that 30 is going to correspond with 42. So I'm going to do 30 over 42. The relationship between those two sides needs to be equal to the relationship between 15 and 21. At this point, you might be wondering, where did I get 21? But I want you to think about it. 15 plus 6 is 21. So that's going to be that whole length in your large triangle. So in the same respect, the length from W to U needs to be calculated as 28 because you have to add the sides. So when we set up that third proportion, it's going to be 20 over 28, okay? Now we're going to hop over into the calculator to make sure that these are all equal values to each other. So 30 divided by 42, 0.71. 15 divided by 21. So those two are proportionate. That works. And then 20 divided by 28 is also the same thing. So these two triangles are, in fact, similar by side, similarity. So the similarity statement for this one is going to be WXV is similar to triangle WYU. So that's your similarity statement, okay? Pause the video if you missed any of that because I know it's a lot to get through. We're going to go ahead and move on to the back side here. We want to talk about side angle side similarity. So side angle side similarity says if two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. So we want to look here at number 5. I have two triangles. The first thing we notice is that angle K is congruent to angle N. So I'm going to color code and mark those. Also, if it's side angle side, that means the sides that are on the side of the angle or next to the angle need to be proportionate. So I want to set up 8 relates to 6 in the same way that 20 relates to 15. If this relationship is proportional, then we know we have a side angle side similarity. I'm going to quickly type this into my calculator. 8 divided by 6 is 1.33, and 20 divided by 15 is 1.33. Because the relationships are equal, that means that these triangles are in fact congruent by side, or not congruent, but similar by side angle side similarity, okay? So if we wrote a similarity statement for these two triangles, it would be triangle JKL is similar to triangle MNP. Okay. Number 6, see if you can pause and figure it out. I'm going to go ahead and work it out now. So I have angle A is congruent to itself by the reflexive property. Okay. And then we need to see if the sides are proportionate or not. So this 15 needs to relate to the longer side, which is 25. So 15 over 25 needs to be equal to the relationship between the small side as compared to the big side, 12 over 21. If they're equal, then we know the two triangles are similar. So I'm going to type these in. 15 divided by 25 is 0.6, and 12 divided by 21 is 0.57. Therefore, they are not proportionate, meaning this is not similar. Okay, so it's important that you actually check those proportions because they might lead you in the wrong direction. Okay, getting close to getting done here, we have a side angle side similarity. So once again, we want to look for that angle that's included between some sides. So I can see here we do have angle E because of vertical angles. Gonna go quicker through this one. So 24, it needs to be proportionate to 6. We need to see, are those two sides proportionate? So 24 divided by 6 needs to be equal to the same thing as 48 in that larger figure divided by the 12 in the smaller figure, okay? Well, I know 24 divided by 6 is 4, and I also know that 48 divided by 12 is 4. Since the relationships are equal and you have an included angle that is congruent, then you know this is side angle side similarity. Once again, the shapes are not congruent, but they are similar. Okay, number 14, pause the video, see if you can work this one out. I'm going to go ahead and work it out now, though. So I have angle F congruent to itself, vertical angles. Remember, X marks the spot. Now we're going to see if the corresponding sides are congruent. So 44 appears to be the long side over here. The long side over here appears to be 27.5. So we are going to set them up proportionally and see if they're equal to the smaller sides related to each other. 40 over 25. So I'm going to divide this out quickly in the calculator. This is 1.6, and this is also 1.6. So though it does have a proportional side relationship, we need to keep in mind that side angle side says the angle needs to be included between the two proportionate sides. So you can see here, this angle is not in between two proportionate sides. It's off to the side. So if we were told that angle J was congruent to angle Y, then it would work with side angle side. But since we were not given that information, we have an issue, and that issue is that they are not similar by side angle side similarity, okay? So that's where we are at on those notes. We're gonna finish these proofs, pause the video, see how much you can get through. I'm gonna go ahead and fill in the answers now. So for number 1, look at the given information. The diagram is already marked with the given information. The parallel lines are marked here with the triangles, okay? And then we're going to go through the proof. So the given information is marked. They're also telling us that angle KMN and angle KJL, this one here, are equal to each other or congruent because they are corresponding angles. I agree. So put a little smiley face. You can see that it's marked there. And then we also have that angle MKN is congruent to angle JKL. That angle is congruent to itself, which means that it is the reflexive property of congruency. Okay? And last but not least, in every proof is always going to be what's asking to prove. So triangle JKL is similar to triangle MKN. Why are they similar? If we look at the diagram, we can see they have two angles that are congruent. Therefore, we have enough information to say that it's angle-angle similarity. So that's the answer to your first proof. Your second proof. The given information is already marked in the proof. We can see that. Looks like we have a blank here, and we need to fill in the missing given information. So I'm looking, we've got this already, so this part is good. but we are missing this given information. So I'm going to write that in. Okay. And then number 2 here, we've got 2 angles that are congruent to each other. So let's trace them out and see where they are. XYW is right here, and angle ZYV is right underneath of it. Why are they congruent to each other? Well, I got to look at the given information above it. So a bisector is going to cut 2 angles into 2 equal pieces. So this is going to be a definition of bisector. More specifically, an angle bisector. So why are the 2 triangles congruent? Well, we can see here that they're telling us that the proportions, so XY is proportionate to ZY, and they're also telling us that WY is proportionate to VY. So since the sides are proportional and the angle included is congruent, then we know this is a side angle side similarity. Make sure you have these notes. You'll want to refer back to them. There's a lot of information here, so pause the video, rewind at any point if you need another explanation. All right, thank you.